Hello, everyone. Welcome to Lambda School's Mini Bootcamp. My name is Deandra Ryan Moss, and I am your instructor. And this is lesson 4, so the last lesson of our first week. So far this week, we have covered a few basic web development topics. We learned how to do some Git commands using the terminal. We jumped into some CSS and some HTML. And then tonight we are going to start with JavaScript. So JavaScript is a huge topic. It's what we're going to actually work on for the majority of this boot camp. So we do have a lot of ground to cover tonight, but it's some really important fundamentals that are going to get you to the point where you're starting to build some really cool dynamic things. So I hope you guys are excited. For those of you who are just joining us tonight, as I mentioned, this is lesson 4. Since we're introducing JavaScript tonight, you're welcome to sit in, even if you haven't seen any of the other videos. Just make sure that you go back and look at those videos so that you can catch up when you're done. So let me tell you a little bit about Lambda School in this mini bootcamp. Lambda School is a 6-month software engineering and web development immersive. So it is a full-time 6-month course where we teach you all the skills that you need to know to get a job in the web development industry. So not only do we teach you everything you need to know, but we also make it accessible to anyone who wants to learn. So we have a de-risked model, which means that you do not have to pay anything when you start Lambda School. We will do an income share with you so that you can go ahead and start, even if you don't have mad funds available right now, and then you can pay back your tuition over the course of your first couple years in the job force. So that means that you only pay us if you get that software development job that you're looking for. So that's a really great option that we have to make sure that this education is available to anyone who wants it. And this mini bootcamp, of course, is totally free. It's available online for anyone who wants to learn. And we especially make it available because it gets you to the point that you are ready to start the main curriculum. So if you're thinking of applying for Lambda School, this is definitely a good place to be because we always prioritize the students who have gone through this boot camp. It shows us that you really are serious about learning this material. Well, let's go ahead and jump into the topic for tonight, which, as I mentioned, was JavaScript. So what is JavaScript? Well, it is a language. It is a computer language. So there are some similarities and some differences between JavaScript and the other languages that we've seen already, which are HTML and CSS. In terms of commonalities, within languages, you're always going to see things like keywords, syntax. So while JavaScript syntax is different and the keywords are different, it is the same in that you have to be really conscious of exactly how you write it, what words you're using, where your punctuation goes. That's always going to be the case when you're learning a new language. It's pretty different, though, from HTML and CSS, especially in that it's far more versatile. So whereas HTML is designed to do one extremely specific thing, which is put elements on a web page, and CSS is designed to do one extremely specific thing, which is style those elements, even though you can do a lot of different dynamic things within that, JavaScript is way more dynamic. So it is a web development language, but you could use it for a number of things. For example, I recently was at the Cracker Barrel, and there's like the little game you play where you jump pegs on top of each other. And I got bored and I used JavaScript afterwards to write a little solver, which told me a way I could move all the pegs to solve the puzzle. So that obviously has nothing to do with web development, but I was still able to do it in JavaScript. In terms of how it fits into web development, it is, if you think about a web page as being a house, then you can think about HTML as being like the framing and the construction. It's where are the walls? What is the shape of the house? Whereas CSS might be the tiling or the paint or the fixtures. It's the style of the house. In that metaphor, you would think of JavaScript as being the electricity, the water, the gas. So it's something that's a little out of sight, but it keeps the web page dynamic. So when you click a button and something happens, when you submit a new post, when you create a new user, all that background stuff that's going on is all JavaScript. So for starters, we're just going to talk about what is JavaScript, how do we use it, and you might not from the get-go see how it fits into the web development puzzle. But by the end of the course, we're going to bring everything back together so that you can use all three of these languages to create a web app. So there are a couple other things I want to cover just in terms of terminology so that you know what we're talking about when we're throwing around these terms. The next one is framework. I know I mentioned frameworks briefly in one of the first lectures, but I want to bring that up again. So JavaScript has a lot of frameworks, which are essentially other sets of code that you put on JavaScript so that you can use JavaScript in a very specific way in web development. For example, there are some great web development frameworks such as Angular and React. React we cover in the main curriculum, and those just make web development really easy and really powerful. So they're something we put on top of JavaScript. We don't cover frameworks in this mini bootcamp, but since you guys are probably going to be hearing that term, I wanted to make sure you knew what it was. Another final thing I want to mention about JavaScript is versions. So when it comes to code and frameworks in general, they're always being updated. There are always new versions being released. The biggest thing that happened in JavaScript a couple years ago is something was released called ES6, which was a new version of JavaScript that actually changed a lot of things and made a lot of things easier or more subtle. So you'll hear me mentioning throughout the course, this is the old way of doing it. This is the ES6 way of doing it. That's what I mean. And generally, good practice in the workforce is you want to stick with ES6 stuff because it's the most modern and it's super cool and we love ES6. So that is a little bit about what is JavaScript. So let's go ahead and talk about how do we write JavaScript. I'm going to go ahead and share my screen and then we can jump on in. All right. So up here, I have a site open called Repl.it. That's repl.it. And this is a sandbox environment. So I've been showing you guys with the HTML and the CSS CodePen, which is another sandbox environment. This is one that's specific for JavaScript. So sandboxes, as I've mentioned before, are kind of double-edged swords. They are really great because they allow us to write code and see what our code is doing with minimal hassle. But sometimes they don't reflect how things work in the real world. So I want to give you guys a little bit of an introduction to how CodePen works. How Repl.it works. So up here is where I write my JavaScript code. I have just 3 lines of code here. I'll explain to you in just a minute what's actually going on here as we go through and learn a little more. But so I have 3 lines of JavaScript code, and then when I want to run my code, there's a little run button over here. So what will happen is JavaScript is always read. In general, code is always read top to bottom. So this line will be run, this line will be run, and then this line will be run. And so something that Repl.it does specifically is the very last line of code, whatever that line of code resolves to is going to appear over here. So when I click run, we see that the resolution of that final line appears over here. And it always has this little green arrow, and it's in green. So we can see that when I've added up this 1 plus 2 variable, the result is a 3 over here. So that is what Repl.it is. Another important thing that you need to know about when just thinking about JavaScript, both in Repl.it and outside, is something called the console. So the console is a way of giving, when you're a developer writing JavaScript code and you need to give yourself feedback, you use something called the console. So let me show you a little real-world example of the console. So I go to Amazon.com. We're all familiar with Amazon, but now I'm going to open the console. So I don't know the command offhand for Windows, but in Mac, it is Option Command J. And this little console appears over here. And sure enough, there's all these random messages popping up. So behind the scenes in a lot of websites that you're used to using, there's some console action going on. So I'm not sure exactly what these mean, but these are some sort of feedback that the developer who actually designed this website wanted to give themselves. So these little notifications pop up over here. So that's the console. Repl.it's way of using the console is that if I log something to the console, like hello, and then run the code, it's going to appear in white. So I'm going to actually move this console log to the top so I can show you something just to be really clear. So the text that appears in white is the console. That's the same as what we see on the sidebar here from Amazon. Whereas the text that appears in green is just the final line of code resolving. So that's a common point of confusion when you're starting to use Replit. I'll probably remind you of it a few more times as we go along. So now that you know how to use Replit, at least in the basic sense, let's start talking about JavaScript. The very most basic thing that we do in JavaScript is we create variables. So we can create a variable called 1, like I did earlier, and set it equal to 1. So let's talk about what's happening here. The first thing I start with is this keyword called const. That is telling the computer that I would like to create a new variable, a new constant specifically. And then this is the name. So I want to create a new variable and I want to call it 1. Then we use a single equal sign, and then I put the number 1 in. This is the value that's being stored in that variable. And finally, you always end with a semicolon. A little note on semicolons, if you leave them off, it still works, but you always want to leave it on. There are a few cases where leaving off the semicolon will totally mess up your code. So good practice is just to put a semicolon on the end every time. But admittedly, you will see me forgetting semicolons here and there, though I try to be good about it. So let's do a little review of what happened here. So I use the keyword const to say I'm creating a new constant. Then I name my variable. There's an equal sign. And then I say this is the value that I want to put into this variable. So now if I go ahead and call on that variable name below, the value pops up. So we've just created our first variable. Now let's go ahead and create another one just to give you guys a better sense. So I'm going to create one called name. I will put my name in. So now if I call on that value name, it's going to pop up the value. So this bit of text, my name, Deandra, is stored in a variable called name. So a little note on how to name variables. We get to choose the name of variables, whereas const is a keyword, and you can tell because it's all blue. This is something we come up with ourselves. So I could name it GarbleGarb, and it still works. I could name it, well, you can't name it numbers. But the point is that it really could be anything, but that doesn't mean we want it to be anything. I could name it just X. The problem with a variable name like X or GarbleGarb is that my future self is going to come back and be like, what in the world is this variable name? Or my fellow developers, if I'm working on a team, will be super confused by that. So you always want to come up with a useful name, and this can actually be more challenging than you might think. And one more piece of convention is that when creating variables in programming, we often use something called camel case. So camel case is something we use when a variable has multiple words. So if instead of name, I want this to be first name, then I would use camel case, which means first is lowercase, but then I start to capitalize once I get to the second letter. So you've got the little camel hump there with the capital letter. So you will see that everywhere in programming. So that is the basics of declaring a variable. Now let's talk about this keyword const. So there are a couple different ways of declaring variables. I will type out all three right here. All right, so there are three different keywords that we can use: const, var, and let. So const is the one that I most often use. And as the name suggests, it's a constant. So if I went ahead and tried to reassign something into one, like 4, and then I typed 1 down here, I get an error. It's saying, hey, you're trying to reassign a constant. So once a constant has been declared, That's it, we're done. And that's actually, that might seem a little restrictive, but it's restrictive in a good way because you really want to be clear about what's going in here. And it's not very good practice to change the values of variables. So we like using const. And const is an ES6 term, so it's actually relatively new in the world of JavaScript. On that note, var is the old way of doing things. So var just stands for variable. And the difference between var and const is that var can be reassigned. So if I go ahead and reassign to 22, now the value 22 is in that variable too, and I don't get any error. So occasionally we will use var, but for the most case, var is a little out of date. So usually we're not going to use it. So let's just get rid of it. We don't like var. The last one is let. Let is another ES6 variable keyword, and it is for cases where we would want to reassign something. So one of the most common cases for let is sometimes we want a little index value just to keep track of things while we loop or something like that. And so I is something that we might reassign because it's just kind of something we use to count in the background. So lets can be reassigned if we want. So right now, I is set to 0, but I could reassign it to 6, for example. And we're allowed to do that. So in summary, const and let are the two variable declaration keywords that we want to use. Const is going to be our most common one, and once we assign it, it is done. Whereas let, we can reassign, and we only want to use it in cases where it would really serve us to actually be reassigning the variable. So that is how we create variables. Now let's talk about running the code a little bit. So notice that if I run the code here, the output over here is undefined. That seems weird, right? I mean, clearly the last line of code that ran is me assigning 3 into this 3 variable. So why are we getting undefined? This is another subtle point, and I don't expect you guys to have your minds fully wrapped around this yet, but it's the kind of thing I want you to be thinking about from the beginning. And that is this idea of code resolution. So if I type 3 down here, we get 3 because this line of code is just the variable name and it resolves to the value of the variable. So all line 3 is saying is grab the variable 3 for me. Line 2 is more subtle. It's saying store the variable, the number 3, in a variable called 3. And it has an action, so something happens behind the scenes here. We create this variable and put this content in, but it doesn't resolve to anything. So when I press run, we get undefined. I will come back to this again and again, this idea of what does the code actually resolve to? Because as I said, it is a really subtle point, but it's key to actually understanding this and being able to use it in a thorough way. Okay, so let's talk about data types. So we've seen a couple of data types already. Actually, let me bring this back. So this variable, 1, is called a number. Pretty obvious, right? You know, any sort of number is going to be a number. We also saw a string. So a string is just any block of text. And we can tell it's a string because we put it in quotes. Another subtlety is this. So this first variable is a number. The second variable is a string. Even if I did actually the digit one, but put it in quotes, it's still a string. So this is more like the text that says the number 1, whereas this is the actual number 1. So if I wanted to do math or increment, I would need an actual number. But if I were just keeping track of, say, an address, it would be okay to put the number in a string. So little subtle point there. Let's talk about a couple other data types. So Booleans is another really simple data type. And Booleans are literally either true or false. To declare them, you either type out true lowercase or false lowercase. This might seem kind of ridiculously simple and like, what is the point of even having this data type of just true or false, but it's actually extremely critical. So behind the scenes at the very, very bottom level, every computer is just zeros and ones. It's just circuits that are either on or off. So this idea of true or false, on or off is really fundamental to how computers actually work. And you'll find that this Boolean, though it seems kind of silly and simple when we first look at it, becomes useful in a number of cases. So these are the most simple data types: the number, the string, the Boolean. There are a lot more that we're going to continue to see. There are things like arrays and objects, which are a bit more complicated. They're ways of holding multiple bits of data. You can also create something called classes, which we'll cover far later in this, which is essentially our way of customizing a data type. And every data type has kind of different features, functionalities, tips and tricks. So it is really important to think about what data type am I actually creating when I create a variable, because they function differently. The very last thing I want to mention is the idea of a typed language. This is especially relevant to those of you who are coming from other languages. So in some languages, you have to declare variables based on their type. So you might have to say like number, use different keywords to declare different types. That is not how JavaScript is. So we use the const or let keyword for every single variable we create, regardless of type. So if you don't know any other languages, I wouldn't worry too much about what I just said. But if you're used to programming in a typed language and you were a little confused, hopefully that clarified things for you. All right, so let's talk about properties and methods. This is one of the key ways that we differentiate different data types. This is one of the reasons it's important to know which data type are we looking at. So I am going to start with properties. So properties are little bits of information that we can get about our variables. So for example, strings have a property called length. When we want to access a property, our syntax is always dot and then the name of the property. So string.length will tell us how long is our string. So in this case, it's just one digit. So even if this were a random letter, we'd always get one. But if I type out, once again, my name, now string.length is 7. So we can find out really easily how long our string is just using this property. If we tried instead to do number.length, we get undefined because this property does not exist on number. So once again, let me put this back to just a 1. And this is another key difference between the idea of 1 the number versus 1 the string. So the number 1 doesn't have a length, whereas the string 1 does. And once again, this thing is called a property. So now let's look at methods. So methods are very similar to properties. The difference is that whereas a property is just one single piece of data that's stored inside of this property, a method is actually a function. So it's more like a process that we call to do something. And that difference is going to seem a little arbitrary right now, but we're going to cover functions in a lot more detail as we get a little later in tonight's lecture. So bear with me for a minute. So in terms of basic usage, methods look very similar. So every single data type has a method called toString. So it looks similar to a property in that I did dot and then I did the name of the method. Big difference is that I threw these little parentheses afterwards. Whenever you call a function, you have to throw these afterwards. Once again, we'll cover that in more detail later. So Boolean.toString just creates a string version of this. So whereas the Boolean value true is kind of this amorphous thing, this is actually true in quotes, which is the string version. I could also do number to string, and it turns that digit 1 into the number 1. I could do string to string if I really wanted to, but it doesn't do much because it's already a string. So that's an example of a method. We will see more properties and methods as we go along. Let me show you just a couple other things that differentiate the different data types. So here's some interesting things we can do with numbers. So let me go ahead and create a couple more. This is the example I had up at the very beginning. If I create two different numbers, 1 and 2, I can do math with these variables. So that works. If this were the string version, we can still use the plus sign, but it has a very different result. It sticks them together. So this is another reason we need to make sure we're aware of what data types we're using, because something as simple as using the plus sign has two very different functions depending here. So let's put these back to being digits. Something else we can do with numbers is use comparisons. So we could do 1 is less than 2, and the result we get out is actually a Boolean. So that's pretty cool. Let's look at, I want to show you just a couple other methods before we move on though. So strings have a ton of methods. Strings have some really cool functionality in them. Let me actually make this longer again. So one cool thing we can do with strings is something called slice. And when we slice, we actually slice off a portion of the string. So I just went ahead and sliced off the portion starting. So I sliced off the first 3 digits because I put in a 3. So I wanted to show you this one because I wanted to show you that sometimes methods have input. Properties will never have input, but sometimes methods have this input that changes the way that they interact. As we saw with toString, they don't always have input, but sometimes they do. So that should give you an idea of what a method is, what a property is, and a little bit about how data types interact differently and how there are different bits of code we can use with different data types. So let me introduce you to the idea of global objects. So all of these variables exist because we declared them. But there are some variables that just exist automatically. One example is console.log, or console. So console itself is a object. So I know that probably looks like a bunch of gibberish, but at the very least, it shows us that this thing is not undefined. So this word console, this variable console, is automatically defined. And as I briefly showed you at the beginning, it has a method on it called .log. And so that is how we get input to the console. So if I do console.log, hey there, it'll appear over here. This is a great reminder of this idea of resolution. So when I do console.log, this line of code actually doesn't resolve to anything. That's why we get undefined in green. So there's no resolution of this code. So undefined. But it causes this effect to occur. It causes this phrase to appear on the screen in white. So white always means console. Green means what does the code resolve to. And there's no way to get text in white except by typing in console.log. So a really good tool for seeing what's actually going on the screen. And another good example of what is a method. And once again, console itself is a global object, which means that it is a variable that already exists without us ever having to declare it. Another example is something called math. So math is an object that just automatically exists. And once again, the feedback doesn't really tell us what it is, but it at least tells us that, yes, we have this thing called math. And as you might imagine, this also has some cool methods on it. So one of my favorite ones is math.random. This gives us a random number between 0 and 1. That might seem kind of weirdly specific, but also one of those things that becomes really useful in a lot of cases. So math.random, this is a method on the global object of math. And in terms of thinking about what actually goes into our method, it takes in no input. So math.random just creates a random number, no need for input. Let's look at a couple others. So we have math.pow, which is how we do exponents. So this one does require input or arguments. So the two arguments that we put in are first two numbers. So I have in the arguments of 3 and 4. That means I want to take 3 to the power of 4. So 3 times 3 times 3 times 3. And we get 81. So math.pow is our way of doing exponents. We also have math.round. I'm going to put in 3.14 as my argument, and it goes ahead and rounds it to 3. There are two other kind of rounding-ish methods that we have, something called floor. So floor rounds this to the lowest whole number. So even if this were 3.99999, it still is going to round it down. Whereas we also have something called ceil, short for ceiling, and this will round up. So even if it's super close to 3, it still rounds up. So those are just a couple of built-in methods on this global object called math. We can use it to create a random number, to do exponents, to round, and to either use the floor or ceiling function. So those are global objects. Now we've been using functions already because, as I mentioned, these methods we've been working with are functions. But functions are a pretty big topic. And in fact, they're what we're going to talk about for the rest of the lesson. So first I want to talk about how to use functions, and then I'll go ahead and teach you guys how to create functions. So we've already been using functions a little bit, so you're ahead of the curve on that one. So let's start with what is a function. Usually we are familiar with the term function from math, and it's kind of this idea of, like, in math you see, f of x equals 2x or something like that. And that means that you put in an input value, your x value, and then you follow whatever the rule says, which would be 2 times whatever you put in, and then you get an output value. JavaScript functions and functions in programming in general are really simple, or they're really similar, excuse me. So we want to think about them as having 3 steps. The first step is we receive some sort of input. The second step is we follow some sort of rule or process. And then the third step is we return out something. So there is input and output, and something kind of mysterious happens in between. And that's the way we want to think about every single function. So let's look at some of the methods, which, as I mentioned, are functions that we've seen already. So I will start with, actually, let's use this math.pow function. So this takes in 2 values, right? If we did 2 and 3, we're saying that our input, our 2 pieces of input, are the number 2 and the number 3. Now, the second step is that something kind of mysterious happens. In the case of pow, what's going to happen is we're going to multiply 2 by itself 3 times. So 2 times 2 times 2. And then the output of the function is going to be that result. We can always tell that a function has output because it will resolve to that value. So here's this idea of code resolution again. So this line of code, this function, has the output of 8. So that's how we would think about that in terms of input and output. Let's look instead at round. So round only has 1 piece of input. Oops, excuse me. Only 1 piece of input, and then it outputs this number, this rounded version of our input. Now let's look at random instead. So random has no input. It somehow creates a random number and then gives us this random number as output. The very last one I want to look at, which is a little tricky, is console.log. And this is where things get subtle. So console.log takes in this string as input, and it actually does not output anything. This is one of the most confusing sticking points for beginner developers. So if you're staring wide-eyed at me right now saying, what is she talking about? Just listen and think about this, and it'll start to come together as you use more and more JavaScript. So remember that the green arrow is the result. This is what this code resolves to. So any output from this function is going to appear in green. And we can see it's undefined, which means there's no output. Of course, hello appears on the console in white. So we do have some feedback as a developer, but it's not actually the output of the function. It's just something that occurs in the midst of the function running. So that's a little subtle point with console.log. Now, I've been using the words input and output a lot because I think they're really basic words that we're familiar with, but I want to introduce you to the proper terminology now. And I'll kind of use all of these interchangeably throughout. So when we're talking about input, there's two different terms that we need to know. One is arguments, the other is parameters. So going back to, let's do math.round. We would say that the number 3.11 is our argument. It's the actual value that we are putting into our function. Parameter is more of a general term. So the parameter would be a number. That's just telling us we want to put some sort of number in. So no matter how we run this, our parameter is always a number, whereas our argument would change. In this case, our argument is 6.7. In this case, our argument is 2.3. So arguments are specific, parameters are general. Another way to think about this with the how example is that you would think about the first parameter being the base, the second parameter being the exponent, because we're taking 3 to the 2. So it's always the case that we have first our base and second our exponent, but the argument is just specific. So in this case, our arguments are 3 and 2, but our arguments could be 5 and 10, or any two numbers really. So that is the difference between arguments and parameters. And I'm working on it, but I do have a bad habit of sometimes swapping those. So I apologize if I make things more confusing, but I will try and keep an eye on using the right word in the right context. The last term I want to introduce you to is a return value. So that is our output. So our return value in this case is going to be this giant number. Once again, in the case of console.log, we have no return value. This function does not return anything, even though hey appears on our console. There's no return value. So those are the basic terms for functions. We have arguments, which are the specific values we put in when we call a function. Parameters, which are the general way of saying console.log takes in a string, for example. And then the return value, which is what is outputted. And you can always tell a return value really easily in Replit because it appears in green if our function is the last line of code that we run here. The last point I want to talk about in terms of functions and how we use functions is the difference between a function itself and a function call. So if I just type console.log without parentheses, this is a function. This is as I mentioned before, there are a bunch of different data types in JavaScript. This one is a function. That is the type of thing it is. So if I run it, it doesn't tell us what is in the function, but it says, hey, this thing is a function. So think of this as being potential energy. We haven't actually called the function, but it exists. I think an even better example actually is math.random because it does give us an output. So if I do math.random, we see, yes, it's a function, but we haven't gotten a random number. That's because we haven't called it. So we don't get a return value when we have just a function, but it's more the potential to receive a return value. When I throw parentheses on, I have now called the function. So now this thing resolves to a number. So this is not a function, this resolution, this return value, it's a number. That's because the function has executed and we're left with the result. So whenever you want to call a function, make sure you use the parentheses and put any parameters that you need inside of there. And so one little memory clue to help you remember that you need the parentheses is think about this as a button. If you press the button, the function executes. If you don't press the button, you don't get the result of the function. So now let's talk about writing our own functions. So there are a few different syntaxes for creating functions. The first one looks pretty similar to what we've seen already. I'm going to start with my constant keyword. I'm going to call this func, which is a very specific name. And so this looks like everything we've seen so far, right? This is how we declare new variables. We use the const keyword, we name our function, we have a single equal sign, and then we want the keyword function, parentheses, and brackets. So let me go over this again. This is a little more dense than what you've seen so far. So when declaring a function, you use this keyword function, followed by parentheses, and then these curly brackets. And everything that goes inside is the actual function logic. So our function could be extremely simple. For example, we could just have a function that returns the number 9 every time. So in order to specify our output, our return value, we need the keyword return and then whatever we want to return. So this return value has to go at the end. Once we hit this return value, the function will be done. So if I threw a console log down here, this line of code would never run. So we don't want to write anything below our return value. Actually, I'll leave that in there just to demonstrate later. Okay, so I've created an extremely simple function here. I'm actually going to name it something a little more specific. So it'll be called get9. So it has no parameters, no input. It just returns 9 every time. So in order to call my function, I need to say the function name followed by parentheses. So I run it, and I get the number 9. And notice that the console log statement never runs. If I move it to before the return statement, now we see that this code resolves to 9 and that we get our console log as expected. So let me get rid of that. So there is our first function, get9. Another important thing to note is that if I try to run my function before I write it, it's not going to work. It's saying get9 is not a function because I haven't declared it yet. So this is the first way of declaring a function. Let's go ahead and declare that exact same function in a separate way. So I'm going to do so this is a little more sleek, and let me actually comment this out, which even reminds me, code commenting. Every single programming language has a way of commenting out code. I think we saw it a little bit in HTML already. So in JavaScript, it is either // or you can also do something that looks like, oops. So a little double slash and a star and then a / star at the, wait. Hey. Isn't that right? Well, apparently I can't remember how to comment out code this other way. Sorry, guys. There is another way of doing it, and my brain is broken right now, so I can't remember it. But anyways, commenting out code. This means that these lines of code will not run. So if you want to test things out or put a note to your fellow developers, you use code comments to do it. All right, so let's now look at the second way of declaring get9. So this time, we don't actually ever use the constant keyword. We're not creating a variable in that familiar way. We just use the keyword function followed by get9, and then we have parentheses, brackets, and down here we can write the content of our code. And what's really cool about this style of variable of function declaration is that now it doesn't matter where it is on the page. We can actually call this function above the declaration if we want. So that's kind of nice. The final way to create a function is actually an anonymous function where you don't even name it. This won't work in this context. There are very specific contexts where we use anonymous functions. I just wanted to introduce the idea to you, but we won't really get into them until some later lessons. So let's go ahead and comment this back in, and then we can talk a little bit more about some cool stuff we can do with functions. So get9 is a nice function because it's super simple, but it's not doing anything very interesting. So let's try to create something a little more dynamic. I'm going to call this add1. So add1 is going to have an input as well as an output. So whenever we want to specify parameters, we go up here and check out the little parentheses. So over here, we could say number. That is a parameter. So we're saying this function will take in a single number, and then we're going to do something to it. So in this case, we're going to return number plus 1. So let's make sure that add1 works. So if I put in 5, looks like it works. We took in, now in this case, 5 is our argument. If I changed it to 9, 9 would be our argument, but number is our parameter. So we take in one number and we return that number plus 1. So let's do something slightly more sophisticated. We'll just call this add. So this is going to take in 2 parameters, first number and a second. And in this case, we will return num1 plus num2. So if we add -8 and 3, we get the result of -5. So we can see that we can have multiple parameters, one parameter, or no parameters. We can only have one return value, though, as we'll see in later lessons, sometimes you use the keyword return more than once. But one function can, or a single function can only return one value. But we also can have functions that have no return values, like console log. So for example, if I wanted to say, create a function called say hi, and let's have this take in a name, and then we want to console log hello name. And this is, I'm using console log in a slightly different way. So we can actually put in 2 arguments into console log, and it will log both of them with a space between them. So now we're going to console log hello plus the name. So if I do say hi to myself, notice that there's no return value because, as I said before, the green arrow, the green text here is undefined, which means this has no return value. And it's really easy to see now that we've written ourselves because we haven't put in a return statement anywhere in here. So this function has no return value, but it still does something. It logs hello and then this name to the console, which we can tell because it is in white. All right, so we have gone over a lot tonight. We have covered just what is JavaScript in the general sense. I showed you guys how to declare some variables. We went over different types of variables that you can declare. We talked about properties and methods on those variables. We talked about global objects like console and math and the different methods and properties on those. And then finally, we covered functions. What are functions? How do we use them? This idea of input, output, arguments, parameters, and return values. And finally, I just taught you guys how to write some pretty simple functions. So I know it's a lot, but you guys just received a really great foundation for all this cool stuff that we are going to learn in JavaScript for the rest of the course. So we will be sticking with JavaScript all next week and most of the final week. So a lot more JavaScript to come. And as with everything else, there are tons of resources online. So if you're having trouble remembering the syntax of how you create a variable or run a function or what different methods on strings are, all of this is Googleable. So just go ahead and throw things in your Google and you'll be good to go. Well, that is all the content for tonight. As always, you have a homework assignment in here. So you're going to be working a little bit with JavaScript. So I hope you guys are excited to jump into that. We do have 10 minutes left, so I'm going to open up the floor to any questions. Go ahead and post those in Slack. Okay, so Erin asked about these two different ideas of declaring function, these two different versions of declaring functions, like if you would use the const keyword or not. So I personally don't have a hard and fast rule about when to do this, but I like to use this style of function, say hi, etc. For one, it's just less words on the screen. For another, it's as I showed before, you can declare the function at the top of the screen or the bottom of the screen, and it works the same each time. So this to me seems like the preferred way to do it. And I just stick with this in almost every case. If anyone out there has another reason that they specify between the two, that's perfectly fine. One thing I do want to show you about when I would use the other is if for some reason I needed another variable that does exactly the same thing as say hi. Let me actually write this out real quick. So name and console.log hello name. So if for some reason I wanted another copy of the variable that does exactly the same thing, or another variable with the exact same functionality, I could use this, I could create a new variable using const and then save this one into that one. So now I could use say hi, or I could use say hello, and they'll do the same thing. So usually I'm not actually using the const keyword with functions unless I'm doing something weird and tricky like this. That's my personal choice, and different code teams and code bases will have different reasoning for different function declaration styles. So that might be a little bit of an unsatisfying answer, but that's how I approach it. Any other questions? All right, I'm not seeing any other questions, so we will go ahead and close out for tonight. Right when I said that, a bunch of people started typing. So I will wait and let them ask what they want to. Oh, it looks like everyone's just saying thank you. Thank you guys for watching. It's always great to have you, and it's especially great to have you guys on Slack interacting, because then I feel like I'm actually teaching to students, which is fun. So that was our introduction to JavaScript. That is the last video for this week. So you guys have the whole weekend to work on the assignment and catch up on anything else. As always, we will be in Slack to help you out. I will probably not be around so much in the next few days. So instead of direct messaging me, just make sure you're posting your questions in the questions channel. And then next week, we're going to learn how to do a lot more cool stuff with JavaScript. So I will see you guys on Monday. Have a great weekend.